All right, so good evening, everybody, once again. And it's so good to have everyone here. And welcome to today's training session from the Spatial and Data Science Society of Nigeria. And I promise you, it's going to be a good time together. So, my name is Ajibola Alade, and I'll be your host for this session. And I'm a geospatial analyst too. So, as we know, this training session was organized by and brought together by the Spatial and Data Science Society of Nigeria. And just for us to know, the Spatial and Data Science Society of Nigeria is a community of geospatial professionals, just for us to be able to unlock networking opportunities, our career advancements, and so on. And as we know, we have the corporate membership, we have our professional membership, we have our associate membership, and also we have our graduate membership for graduates. So it's really a nice community to be in, and it's a community whereby you'll be able to learn from like minds within the geospatial community and even beyond. So today we'll be having Mr. Ezekiel Ogungbemi is going to be our facilitator for today, and it's going to be a nice time together. It's going to be taking us on spatial and network and routing analysis. So give me some time. Let me introduce our facilitator for today, and who would kickstart. So um, and who will kickstart? All right. Ezekiel Ogungbemi is a geospatial analyst at Basical Technology Limited with over 3 years of practical experience in using spatial data and geospatial technology to address environmental challenges and support sustainable development goals. He is experienced in facilitating and organizing workshops, conferences, is experienced in facilitating and organizing workshops for open source community and conferences, and he has a flair for simplifying geospatial concepts for his audience. He is also a first class graduate with a major in remote sensing and geoscience information system, and is an active OpenStreetMap contributor within the Earth open source community. And his interest lies between environmental monitoring, sustainability modeling, geostatistics, spatial statistics, network analysis and routing, and also cartography. He also has great interest in integrating statistics and machine learning model to be able to create formidable solutions and automated workflow. So Mr. Ezekiel Ogungbemi is bringing his hands-on experience to today's session, and is going to focus on network analysis model that geospatial professionals can deploy to solve real-world routing and accessibility platform. So everyone, welcome with me, Mr. Ezekiel Ogungbemi. Thank you so much, Mr. Ezekiel. You have the floor now, and you can kickstart the training session.
Good evening, everyone. Good
Yeah, good
evening,
evening,
everyone.
Mr. Ezekiel.
All right. Thank you, Mr. Ajibora. Thank you. And I want to say a big thank you for this platform from the Spatial and Data Science Society of Nigeria to be able to facilitate this session. Okay, so I'll just go straight to the workshop session as I have quite a limited time to give us a strong background about what network and routing analysis is, and also do a few practical demonstration on how to use this particular analysis. Okay, so I'm just going to go right straight and share my screen.
Yeah, Pela.
All right, so I'm unable to share my screen. Says that host disabled attendees screen sharing.
Oh, let me do that. Let me give you the permission to.
All right.
Sorry, give me some time. I'm trying to figure it out.
Okay, that's okay.
Okay, can you try sharing it again now?
I'm still unable to share it.
Okay, I will make you an host then, so that. All right, try it again now.
Okay, that worked fine. Kindly confirm if you can see my screen.
Yeah, I can see it. Thank you so much.
All right, so once again, my name is Ezekiel Ogungbemi, and I'm a geospatial analyst, right? And I use geospatial technology to address environmental challenges, ranging from environmental monitoring, disaster response, and network and route analysis, as the case may be in today's session. So I'll be anchoring this session on network and route analysis, and I'll give us a brief demonstration on how to utilize this to actually solve real world problems. So before we go into what network analysis is in GIS, network analysis is actually used in other sectors also, because if we break down the terminology, there is network first, then there's analysis before you now bring them together. So network basically is a system of interconnected elements, and these elements include edges, junctions, or nodes, as you may call it, linked together by a series of connected lines and linear features. So those linear features are basically the edges. They define a relationship between, you know, um, a series of nodes in the network, or let me say in a system. So that entirely creates what we call a network. So when we say a network analysis, basically we are introducing mathematical and visual approaches study to study complex systems, or to study the relationship between nodes, or those elements in that network, right? So basically, okay, yeah, it enables professionals to study the relationship between interconnected elements, defining constraints that limit the flow of values within the network. So at a particular point in time, while you want to define you want to define the relationship between a particular node and another node, there might be a constraint between the movement, the flow of values between those nodes. So that constraint needs to be considered when you are developing or designing a network model. All right, so now what exactly, okay, so network analysis in GIS, basically we just introduced the spatial components from, geographic information system. So it enables professionals to study the relationship between interconnected geographic features, like roads, utility lines, amenities which include schools, healthcare, goods and services, and these amenities are represented as nodes, right? Network analysis in GIS also models connectivity. It helps us to understand how a particular node is connected to another. Okay, just move on. So now, when it comes to developing a network model, when it comes to performing a network analysis in GIS, in the case of this work, so we are particular about the use of ArcGIS. So when it comes to performing network analysis, it's important that ArcGIS, imputed into the software that hosts all the necessary components that we need to perform a network analysis. And that model is called a network data set. So this is one of the terminologies in network analysis, in GIS, that is very, very, very paramount, a network data set. So it's a built-in model designed to host all the necessary components, to successfully perform a network analysis, right? So without this network data set, you cannot successfully perform a network analysis in in GIS, in ArcGIS Pro. So let's look at the features of a network data set basically. Number one, network data set is responsible for putting into account, for recording all the connections between the elements in a network. And these elements include the lines, the points, and turnings, right? So the network data set is responsible for recording the connections between these features. It connects all these features in the network, and stores that connectivity in a particular, will I call it now, a database, which is not going to be visible to us, but it has it stored inbuilt, in the software. Then the network data set also enables us to define rules, policies, like I was saying earlier, constraints. Okay, in the process of finding the shortest route between point A and point B, ensure that the vehicle does not pass through this river. So there could be a river between point A and point B. And if we define the shortest route to cross that river from point A to point B, then we have not really considered the realities of nature in our network, in the network model we are building. So network data sets enables us to be able to say, okay, while defining the shortest path between a particular point and another point, consider this natural feature, right? Consider this natural feature. Then there are other rules, at a particular point in a road. Some roads you are not permitted to make a turn at a particular point. So that's a restriction. That's a rule. That's a policy that can be imputed in network data set. Then the network data set informs the solvers on feasible paths along the network. We'll get to know what solvers are in the next slide. Then network data set also accommodates multimodal networks. So basically, when I was talking about networks, I mean the linear features in a network. For in the GIS context, the linear feature basically are road networks, are road networks. But you know, network data set can accommodate multimodal networks. In other words, it can accommodate it can accommodate other mode of transportation such as railways, um, airlines, right? That's in the aviation industry, water network, um, railways, trains, roads, aviation path, right? So network data sets can actually accommodate these multimodal linear features. So in the network data set has a set of tools, basically. The first one is the build network. So earlier on, I was saying that the network data set, records the connectivity between the elements in the network. The major tool that is responsible for recording that connectivity is the build network. During the demonstration, well, I'm going to explain how this build network works. After we have defined all the rules, we have defined the network data set, we've imported all the features, both the line features and the point features. Before we can start performing any network analysis, the first thing we need to do is to build the network. So when we are building the network, we are telling ArcGIS Pro, yes, we are kind of sending a message, to ArcGIS Pro that, all right, please ensure that this network data set has the connectivity between all the elements that has been imputed into this data set. Then we have the create network data set, create a template from a network data set. So if you have an existing network data set for a particular region, you can actually create a template from it. Or if you define a new network data set, you can create a template from it such that another professional can use for that region. So the constraints I was mentioning earlier, we have the travel time and distance. So for each road, there is a maximum speed limit, you know, that can that is permitted for vehicles, motorcycles on that road. So it is very important that we take account of that in our analysis. Barriers, like I was saying earlier, you know, some roads are can be blocked, maybe due to craters or potholes that have expanded. So vehicles cannot actually pass through that road. Those blockage on that road can actually be accounted, can be recorded as a barrier in our network analysis. Then flooded roads or closed pipeline valves. Then directions also, one-way street rules, return restrictions. So these are examples of constraints. Now, there is what we call solvers, network analysis solvers, or you can say network analysis tools. So after you have defined your network data set, after you've defined your network data set, you've set the rules and all of that. Then you now talk about the solvers. One of the solvers, which is the shortest path, or routing. So you want to know the shortest path you're going to take from your house, to a particular eatery, or you want to know the shortest path you're going to take from your house to a clinic, right? So there is a particular solver, there is a particular tool specialized for that calculation, right? Such that you just need to input your data, the origin where you're starting from, then it's going to give you an output. The output is going to be a road net, a road. It's going to select the road that has the least cost, um, the least cost factor. And the cost factor we are talking about is probably the road with the shortest time interval, or the road with the shortest distance. So it's going to highlight that route, and you're going to use it for your probably to establish a policy or make your decision. Another one is service area. So basically, the service area is used, when you have questions like how many facilities or how many households is going to benefit from my commercial service in a particular region. So for some of us that are probably retail business owners, or for some of us that have a proprietary business, you know, and you just arrive at a particular location. So you want to know an estimate of, the households that your particular business is going to serve. So you're going to use what we call service area. Now, this service area is very, very, very similar to buffer analysis. Service area is very, very similar to buffer analysis, but there is a very, very clear difference. And what's the difference? Remember, we are talking about network analysis, and in network analysis, we are considering road networks, and these road networks have estimated time of travels. So basically, you're not just buffering around your business location just to know the coverage at which your business is going to cover. No, but you are also considering the time your demand is going to come for your service, or the time probably you have dispatch riders, the time your dispatch riders it will take for your dispatch riders to get to your demand location. So that's the clear difference between service area and buffering. Service area puts into account time, the time it will take for a service to get to your demand. Buffer is just basically about distance, right? It's about distance. So it does not consider the movement of goods and services along road networks. Closest facility. So you want to know the closest facility to a particular incident. A very good example is um, this IDP camps scenario, whereby there are refugees that have to escape from attacks, and they have to reside in particular refugee camps, internally displaced persons camps. So network analysis can help us understand the closest facility, or how the accessibility to those healthcare facilities by those refugees, right? So that's a very, very good example of closest facility. Now, location allocation. Location allocation is a compound description, right? Location allocation is a compound description in the sense that you want to locate you want to locate a where a service is going to be located, an optimal location where you can establish a service, and the number of you know demands that service is going to is going to serve in that location, in that region. A practical example of this also is warehouse and stores, warehouse and store. So for retail people, they go to a particular manufacturing industry. Might not be where they are it might not be where they are actually doing the work to design the product, but probably after they design the product, they have to take it to a particular warehouse such that retail people can come there and buy in retail before they now go and sell. I mean, buy in wholesale, pardon me, buy in wholesale before they go and sell in retail, right? So you want to locate optimal locations where you can establish warehouse such that that warehouse is going to serve a number of stores, retail stores, within a specific time. Within a specific time. I want to move fast. So the next one basically is origin destination cost matrix. Origin destination cost matrix. So all of these solvers basically are very, very connected to each other. But you just need to understand where you can apply them in particular. So for the ODA cost matrix, it finds the least cost path from several origins to a particular destination. It finds the least cost path from several origins to multiple destinations. So the advantage of this one is that it allows you to specify the distance, the search distance, or the search time. Okay, um, within this particular origin to like 500 meter away, how many destinations do we have close to that origin, right? So that's what the origin destination cost matrix does. So moving on to the next slide. Okay, application of network analysis. I believe I've mentioned a few of them while um, I was explaining the network analysis solvers. Network analysis is used in pipeline industry to be able to detect, no, not to be able to detect, pardon me, to be able to plan, how, the pipelines will be installed, you know, will be stored in a particular region. There is an advanced path, there's an advanced analysis for, not really advanced, but just like another, like an offshoot from network analysis. So that one is like MCD for some of us that are familiar with that, multi-criteria decision analysis. So to be able to plan where pipelines can be installed, such professional we need to consider natural features like the geology of the region, um, water bodies, you know. So we need to factor those ones in. So that's like an offshoot also. But even just by studying, if you want to study the flow of oil in a pipe, you can use the network analysis in GIS. Then we have network analysis in finding the closest bus station and real-time routing. Yeah, real-time routing. In public health, yeah, network analysis is used in public health, assessing the closest, or rather studying the accessibility of healthcare, in a region. Then you can also define a service area for healthcare facility, close to maybe incidents or attacks or amenities, maybe like schools and the likes. Then, yes, network analysis is also used in agriculture. Now, for large scale agriculture, industries whereby they produce on a very, very large scale, they will have a very large amount of crop residues, right? So they will need to find the optimal location where they can store those residues, for maybe um, biomass fuel production or what have you. And the last one, fire service and emergency, trying to find the optimal route for quick response in the case of a particular incident. So while I was preparing this slide, I just thought to add this comparison between real-time routing and ArcGIS network analysis. So, real-time routing, basically you can, if you go to your Google map and you want to find the nearest eatery in a place you're not really familiar with, and you type from your location to probably an eatery, you just type an eatery, and the your interface just starts moving and it gives you an optimal path. So that is what we call real-time routing, basically. So what makes that different from the network analysis that we are doing in ArcGIS Pro? So for real-time routing, there is the cloud-based routing engines. These engines are responsible for the calculations that we're using the network analysis solvers to do. So these cloud engines are responsible for the mathematical calculations. Okay, this is the shortest path and all of that. So an example of that, an example of these routing engines are the Google, the Google open source kind of engine, right? Or the cloud-based engine responsible for feeding the Google map. That's an example of such kind of engines, right? That does the calculation work inside. Then there is the API and the SDK. Now the API basically is like a messenger, right? That is installed or developed with the app to send direction instructions from the user to the engine. So when the engine does the calculation, then the API comes back and delivers it to the user. And the SDK basically gives us the interface that we are seeing on our phones, on our devices, right? So okay, so the real-time navigation is designed for immediate end user needs. So you want to quickly know where you are going to, in a place that you don't know. She understand. So you don't have to come to ArcGIS Pro to now start performing one short route analysis. So all you just need to do is to go to a navigation app and you find your best location. Then for real-time routing, they get their data source from open source data sets such as the OSM, right? Unlike we customize our data sets to suit the analysis we want to perform, right? Real-time routing um, system actually gets their data from an open source platform. And the real-time routing is designed for the mass, like is designed for the general consumers, general users, basically. On the other hand, the ArcGIS network analysis, is customized for in a um specific scenario. You can control, what you can adjust, you know, um, policies, rules, to get what you want to use the analysis for. There's no need for API there's no need for API basically, but there are some advanced implementation that you would require the use of APIs, but that's beyond the scope of this workshop, right? So yeah, there's no need for API. The SDK, ArcGIS Pro basically provides the best environment for us to be able to perform the network analysis, right? Then network analysis in ArcGIS Pro is research focused, to be able to derive insights, to be able to answer research questions, to be able to derive insights so that we can, organizations, either private or public, can make informed decisions as regards commodities, flow of goods and services in a particular region. All right, so I came up with a simple, like a defined workflow. Okay. So I came up with a defined workflow for, the um for network analysis in ArcGIS, and I'll just delve right into the demonstration while I follow this workflow. Mm, okay. Please, I want to get a feedback before I go ahead so I can know that. Um, all right, thank you. Um, how to stop sharing. Okay, please confirm if you can still see my screen.
You can see your screen, sir.
All right, thank you. Okay, so the workflow for performing a network analysis is is straightforward, but is very, very, very technical in a bit, because if you don't pay attention to certain details, in the process of um, you know preparing your data sets and all of that, if you don't pay attention to certain details, you'd be having certain errors when you get to a particular point like that. So let's just get right to it. So the first step, right, is to define the problem. Like, what do you want to solve? So I picked a study area. Of course, you have a study area where you want to work on. So I picked a study area somewhere in Imo State. That's Uweri. So here's my study area. It's the capital city of Imo State, right? And it's a region bubbling with commercial activities, and it's very, very active. And I had to pick it also because the road network of this region is very, very um, fine-tuned to a very large extent. And that's one of the things, that's one of the criteria, one of the things that needs to be taken with utmost importance. You need to ensure that the road network of that region is very, very um, cool. So there are platforms where you can source your data from, and a very, very good source is the OpenStreetMap. The OpenStreetMap. database. It's very, very, it's kind of is updated. If it's not updated, all you just need to do is to zoom in close and edit the network to be updated to the region. So I got the network, the road network of Imo State. Then I also got a few point data, the town, residential regions, parking, marketplace, commercial, college, cafe, then amenities. So I'm just going to turn off this residential because it's making, yeah. So once you have, these are the two major elements in a network basically are the nodes and the linear features. So the next thing now, or the first thing now we need to do is to define, the problem. What problem can we actually solve in the municipality, that's Owerri municipality in Imo State, right? So we have cafe, college, commercials, marketplace, parking, residentials, and all of that. So while I continue, I don't know if anyone can just type in the comment section like what problem can actually be solved with all these points data. Having known the fundamentals of the network solvers, the shortest path, service area, um, location allocation, closest facility, OD cost matrix, right? What problem can actually be solved with these point data quickly in like 2 minutes? Anyone. All right. I'll just um go ahead. So one relationship actually that we can study here is the relationship between hospitals and schools. So for the amenities data, we have schools, universities, and hospitals, in this data set. So we can study the relationship between these two amenities. Like for schools now, probably there is a major health issue that needs medical attention. So what's going to be the closest, healthcare facility to the school? She understand? Or what's the shortest route to the school? So that's one problem that can be solved. And the tool that's going to be used for that is the closest facility. So after defining that, the next thing is to prepare your data and clean it. Data preparation and cleaning. So the first thing I'm going to do is for the street data, I'm going to open the attribute table and study the columns. So we have the highway column, which consists of primary, secondary, I believe tertiary. So we want to know, um, so we have primary, residential, secondary, tertiary, and unclassified. That's about five of them. Then most of them are just one way. Then we have two lanes. So there are two columns that are needed in our road data set before we can start working on network analysis. The first one is the maximum speed column and the length of the road. And we also need the time in the road. So I'll go to my catalog, right? I'll go to my catalog. Now, in your folder, the first thing you need to do basically is to create, um to create a geodatabase which has already been created. You create a file geodatabase, but that has been created here. You open it. Inside, okay, I just need to create a new one. Oh, sorry. All right, so SDSSN demo. All right, so inside your geodatabase, you need to create a feature data set. SDSSN, um, network. Now, very importantly, we need to set the coordinate system. Um, Now, we need to set the coordinate system to a projected coordinate system because we are dealing with road network, and the measurement of the length needs to be in meters. If we leave it to be in the geographic coordinate system, the measurement is going to be recorded in degrees, and that's not what we want. So there is a particular coordinate system we're going to be using, under wood. Um, Sorry, mine projected. Okay, UTME, Africa. So you locate, not me now. I'm not going to use this because it's going to change. It's not going to give me what I want. So yeah. So this is it. Under UTME, the WGS 1984 Northern Hemisphere. So we locate WGS 1984 31, UTME 31, zone 31, and this is it. So we click on that. So we set the coordinate system of the feature data set, then we run. So we open the network data set. So this is where we start, the major work. So we create the network data set by right clicking, go to new, and here we have network data set. So we have the SDSSN um, demo, or let me just give it Owerri ending. Now, that has been done, but you can see that this source feature class is having an asterisk. There is meant to be a list of features here for us to select as our source feature classes. So the source feature classes are our nodes and road network that we want to use to define and design our model. So we can't create our network data set yet. What we need to do it first is to transfer our road and node point data into this network data set, feature. So I'll go back to this point where we have our data set, or rather, let me just go to the map. So what I'm going to do is I'm going to export. So I'll export the features, but in the process of exporting the features, I'll ensure to go and select. So here I tap query. Now I go to the environment and I set the coordinates to be the exact same coordinate reference system of the network data set. This is very important, else you won't be able to transfer your data to the network dataset feature, and you'll not be able to run your analysis. So after doing that, then click on OK. So the next thing I'm going to do is, because of time, please can I know the amount of time I have left, so that remove. So I'll export this as well to, you know, okay. All right, can anybody hear me? Right. Okay, thank you. Is Mr. Ajibola on the call?
All of that, right?
All right, okay. All right, so I'll take out this. So what I want to do now is I want to separate the school features and the hospital. So quickly, I think I have that already. I don't know what happened with that guy got corrupted. Okay. All right, so now I have the Owerri School, Owerri Health, and Owerri Street. So before I go on, um, I need to know what attribute table. So now, highways, primary highways have a speed limit of, I think that should be 50 km per hour, right? So what I'll do is go to highways, select the primary. I actually did not skip this process because it is part of setting up the network model, right? So I'll go to the select, the, yeah, in this place, I'm just going to put in, I'll just use 50. Okay. Then for secondary, primary roads connect, kind of connects, I think that's states. Primary roads connects one state from to another, while secondary kind of connects local governments, you know, to each other. So the speed limits will vary. Calculate field. So I'm going to use 40 km per hour for this one. So for tertiary basically connects towns, to each other. So we're going to use 30 for that. But we are not done yet, right? So we still have residential. So residential, we need to just bring down the limit to like 20 km per hour. Oh, let me ensure that. Okay, max speed, apply. And then unclassified. So for unclassified, I'm going to use 20 as well. I mean, though it varies, but I'm just going to use 20 as well. Okay, apply. So we would see that all the max speed has been populated. So the next thing we need to ensure is that this shape length automatically came in because we set the coordinates reference to a projected one, right? And this length is very, very important. So the next thing that we need to calculate now is the time. So we just need to add a field and just call it time. So give it double, and I think that's pretty much it. So we close this back, then we come to the time column. So we calculate the field as well. So we calculate the field. So now for the time column, time is calculated by speed is equal to distance over time. So time becomes distance over speed. So the distance is the length of the road divided by the speed. But there is an issue, and the issue is that the distance of the road is measured in meters, while the speed is measured in kilometers per hour. So there has to be some conversion, right? So the first thing we want to do is say, um, is the distance that's going to be on top. We want to open a bracket. Okay, there's no bracket here, right? There's no bracket. There's no bracket. So I'm going to create a bracket. Then we're going to locate the speed. Now the speed is kilometer per hour. I mean distance over time over speed. Pardon me. So I'm going to locate the length. I'm kind of in a hurry because I'm not sure how many time I have left. So I just want to finish this setting up the setup stage, so that I probably would schedule another one for another meeting for the solvers. So the shape length is in meters, so we need to convert it to um should we convert it to kilometers so that it's going to cancel out that, or no, we need to convert the kilometer to, all right, so let's just do that. So I would say this divided by, so the max speed, right? So from kilometer to meter, that's going to be divided by, I mean multiplied by 1000. Then this is turning my head upside down. Okay, km times 1000, right? So that will be, okay. Yeah. So yeah, that's the time. Then apply. Can multiply sequence by non-int of type float. Okay. So I just incoming. Sorry, what was the error again? Okay. Hmm. Okay. Still running, still running, still running, still running. 9:15. All right. So we have our time already in minutes. In minutes. The conversion I did was what in minutes. So now we can now go to, yeah. So this is the network analysis data set. So we right click, basically right click inside this place and go to the network data set. So there are different ways you can, create the data set. You can also create it from the geoprocessing tool by simply going to the toolbox, locate the network analysis, network data set, and create network data set. But the advantage it's going to give us is it should have located the geodatabase for us already. So I'm going to select this and say Owerri ND. I would select no, I'm not using amenities. So it's just street, health, and school, and run. All right, so now we have our network data set. By now it should have been added to the it should have been added to the map layer. If we turn this off, I think we need to turn this off as well. All right, so before we go ahead, you need to remove this from the layer pane. Else, we won't be able to edit the network data set from this point here. So we go to the ORI-ND, right click on it, then we go to the properties. So this is the build I was talking about, build network, but we're not going to build it yet because we need to set the rules that will govern we need to set the rules that will govern, the flow and direction in the network data set, in the network analysis. Is once again, can anybody still hear me? Okay, I need a feedback. All right. I need a feedback, please. Okay. All right. So what we go to our okay, no, we're not going to be dealing with the source settings. We just go straight to the travel attributes. Okay, so travel modes basically are yeah, the modes of traveling on a particular route can either travel by driving or by walking, right? Driving or walking. So there's either the driving distance or driving time. So to create a new driving mode, just come click on this three bar and we have the mode defined already. So there are no modes defined. So we are the one that was going to define our modes. So I'm going to just say driving distance. Collection of network is settings that define actions that allowed that okay, so um let's put road distance. Driving, yeah, driving. So we have the length already selected, the time cost. Now this will not record as there won't be any record there. So I'm going to add another mode. I'm going to call it driving time. Okay. Now see. Okay. Please, at this point, I would really like to know for how long I would can still go further. It will really, really be helpful for me. Yeah, Mr. Ajibola, can you hear me? Okay. Time cost, driving time.
Hello.
Can you hear me? I can hear
Yes,
you.
I can hear you now. I can hear you now.
All right. So I was saying that I would like to know how much more time I
Okay.
can cover, time it takes to.
All right. I think we can just round up now. So definitely, if there will be a follow-up session, we'll definitely make everyone aware. But honestly, it's been a great session so far. Honestly, I'm really enjoying it, and even not for my network that logged me out. So, but Ezekiel, you can just round up and yeah, we'll move forward from there. Do you get?
All right. Okay, so length is in meters, the costs. Okay, so I need to add another cost, and I'm going to call that time.
Oh, okay. Okay.
Um,
Hello, Ezekiel.
yeah, I'm with you.
Okay, so we really want to appreciate you on behalf of the Special Data Science and Society of Nigeria. Thank you so much for your time and honesty. It's really worth it. And I know that everybody that is here that joined have really learned one or two things on what you took us through, the practical session, even the way, even when you even started with your slide, I was like, this is even enough already because it was really detailed and explanatory. Now going into the practical session. So, and I believe that every one of us here, if it is one or two things, we've been able to pick it and know how to proceed from here. So I know that we've not been able to cover all, but then we'll definitely get back to everyone on how our follow-up session is going to be, and it's definitely going to be much more better than this. So we really want to thank everyone for staying through. I know that we've overspilled time, but it's really worth it. And to our facilitator, we cannot thank you enough. Thank you so much. Can you still hear me, everyone? Please confirm.
Yes, I can hear you.
All right, thank you so much. So our facilitator, Mr. Ezekiel, thank you. Thank you so much. Just like you started in this field of geospatial analysis and geospatial science, you continue to break more grounds. So just we really want to thank you and really appreciate you. So we'll make the slide available to everyone, and we'll give you updates on how we'll proceed from here. Thank you so much, everyone, once again. So have a great night's rest. Thank you.
Thank you.